You're looking at a shot of the Science Center, but we are going to be talking about space specifically. And from the H.R. Macmillan Space Center, we're joined by astronomer Kat Kelly. The biggest science story in the news has been this image that was captured of a black hole for the first time ever. How amazing is this?
It is so exciting. I think people, up until now, black holes are just a thing you hear about, but now we actually have a real picture of one.
Now, we've had an idea of a black hole since Einstein's theory of relativity and what he thought existed. How did we know that it looked somewhat like the actual image shows?
Yeah, so up until now, before taking pictures, a lot of it is done with computer simulations where you take the known laws of physics, or at least as much as we think we know, using Einstein's relativity. And then we would do different models and play around with parameters that we know for sure. And it turns out that this picture is pretty spot on.
Almost exactly. Yeah. So what is a black hole? Tell us what it is.
So a black hole is a region in space where so much matter has accumulated that it curves space significantly. So even the sun, the Earth, all the planets around the sun, you can imagine it like a trampoline, and their mass will curve it slightly, just like when you stand on a trampoline. But black holes have so much mass that they curve it to an infinitely dense point. And the gravitational field is so strong that not even light can escape.
And that is the point. The point is the black hole.
Yeah.
It's the pit of the universe.
There's many of them, so there's many pits.
Of them. Interesting. So how did Einstein believe that this was, in fact, the case?
So he kind of studied, and he was the first one to describe gravity as an effect of that curved space, as opposed to a force of attraction, which that is still correct. Like Newton's laws very accurately describe how objects are attracted to each other because of gravity, but he allowed us to think of the sort of the cause and the why that happens. And so any object with mass will curve space. The more mass you have, the more curved it's going to be.
Yeah. Tell us about capturing this image, what it took.
Yeah, I mean, it's an incredible feat. So you hear of the Event Horizon Telescope, which is actually many telescopes put together. And so there's about 8 observatories that work together to take data in the radio wavelength. So it's still light, just radio emissions. And then there's a lot of data processing that happens after that to sort of model that light into visible light, and then you do that using Einstein's relativity and all the physics that we know is correct. We apply to that data, and then you come out with this picture that's all of the data from all the telescopes combined.
Okay, we're seeing the image here. Tell us what we are looking at. The black hole, obviously no light exists, so we're not going to see anything, but we see light around the hole, on the outskirts of the hole?
Yeah, so the sort of black circle in the middle is what we call the shadow of a black hole.
Okay.
It's very hard to come up with terminology for something that you can't see. So it implies the presence of the bit where the light can't escape from. And then the orangey red ring around the outside, what happens around black holes is you actually end up getting a disk around it of matter accumulating. That's called the accretion disk. And so we have to remember that black holes are actually spheres, right? They're three-dimensional objects.
It's not a flat surface.
Right. Our picture is two-dimensional. And so that's why you see matter all the way around, because you've got this sphere and then a disk. So we're seeing some of the light from the disk behind is bent up and around it, and you end up with this ring. And the brightness at the bottom is because either the black hole itself or the disk or both are rotating.
So is that matter getting sucked into the middle?
It is, yeah, and that's actually one of the science objectives of the Event Horizon Telescope, is to model exactly how that works, how accretion disks do accumulate matter onto black holes.
So that's next?
Yeah, that's what they're going to use the data to try and study a bit more.
What can we find out if we head up to the H.R. Macmillan?
Well, the cool thing about the Space Center is you can come into the planetarium and immerse yourself in this environment where it really feels like you're in space, and we can show you a black hole in 3 dimensions. We're, of course, going to be having the image up.
Yeah.
We'd really like to have current news in the Space Center. So if you want to delve in a bit deeper into black holes and sort of really conceptually understand it, then come along to a planetarium show and we'll show you around.
Perfect. Thanks so much for joining us this morning, Kat.
Astronomer
Kat Kelly from the H.R. Macmillan Space Center.